Welcome to Tech Lab by Sid. What is Platform as a Service? Platform as a Service, or PaaS, is a cloud computing model that provides a ready-to-use environment for developers to build, test, deploy, and manage applications. It offers a comprehensive platform that includes everything needed for application development, such as hardware, software, operating systems, databases, middleware, and development tools, all hosted on the cloud and provided as a service. Unlike infrastructure as a service, which provides virtualized hardware resources, or software as a service, which offers end-user applications, Platform as a Service focuses on delivering the underlying platform and tools for developers to focus solely on coding without worrying about managing infrastructure. Key terms related to Platform as a Service. Cloud computing. A model for delivering computing resources, like servers, storage, databases, networking, software, etc., over the Internet, often using a pay-as-you-go pricing model. Middleware. Software that connects different applications, services, and systems, often facilitating communication between them. Platform as a Service providers typically include middleware as part of their platform. Development tools. Tools and software that developers use to create, test, and deploy applications. These include IDEs, that is, integrated development environments, debugging tools, compilers, etc. App hosting. Platform as a Service provides the infrastructure for hosting applications without the need for developers to manage underlying servers and networks. Containerization. A method of virtualizing application services that makes them portable across various environments, such as development, testing, and production, a common feature in many Platform as a Service solutions. Serverless computing. A form of Platform as a Service where the cloud provider automatically manages the infrastructure, scaling, and provisioning resources based on demand. Developers focus purely on writing functions and business logic. Processes related to Platform as a Service. Development. Platform as a Service provides integrated development environments, or IDEs, and tools for coding applications. Developers write their code using languages supported by the platform, example, Java, Python, Node.js. Testing and staging. After development, applications can be tested and staged using the tools and infrastructure provided by the Platform as a Service provider. These environments simulate real-world usage conditions for debugging and refining applications. Deployment. Platform as a Service platforms automate much of the deployment process. Developers push their code to the platform, which handles the provisioning of infrastructure and scaling based on usage. Monitoring and maintenance. Platform as a Service platforms typically include monitoring tools to track application performance, uptime, and resource usage. Maintenance tasks like patching software or scaling the infrastructure can be automated by the platform. Scaling. Platform as a Service solutions often have automatic scaling capabilities, where resources, example, CPU, memory, are adjusted dynamically in response to demand. Advantages of Platform as a Service. Cost-effective. Since the provider manages the infrastructure, developers only pay for what they use. There's no need for investment in hardware, servers, or other expensive resources. Faster development time. With tools, libraries, and infrastructure all pre-configured, developers can focus on writing code rather than managing servers or setting up environments, speeding up the development process. Integrated tools. Platform as a Service platforms often provide integrated services like databases, analytics, monitoring, and security features, which streamline the development process. Scalability. Platform-as-a-service platforms offer automatic scaling, meaning applications can be adjusted in size according to user demand without manual intervention. Maintenance and updates. The cloud provider handles maintenance, system upgrades, and patching, reducing the overhead for the development team. Collaboration. Platform-as-a-service environments often include collaboration features that allow teams to work together on projects with centralized resources and tools. Security. Many platform-as-a-service providers implement advanced security measures, including encryption, firewall protection, and authentication mechanisms, thus reducing the risk for developers. Disadvantages of platform-as-a-service. Limited control. Platform-as-a-service platforms often come with restrictions on the choice of operating systems, programming languages, or database engines. This limits the developer's flexibility compared to managing infrastructure directly, example, infrastructure as a service. Vendor lock-in. When you build an application using a specific platform as a service platform, it may be challenging to migrate to a different provider without significant modifications to your code base or architecture. Complex pricing models. Some platform-as-a-service solutions have complicated pricing models based on usage metrics, example, CPU hours, bandwidth, or storage. Predicting costs can be difficult without careful management. Performance overhead. Platform-as-a-service solutions, particularly those with higher abstraction layers, can introduce performance overhead due to the additional layers of virtualization and resource sharing. Limited customization. Platform-as-a-service platforms may not allow full customization of the underlying infrastructure or hardware, which can be restrictive for applications with specific performance or security requirements. Dependency on provider. Since the platform and infrastructure are managed by the provider, outages or service disruptions can impact your applications, even if they are otherwise well designed. Characteristics of platform as a service. Abstracted infrastructure. Developers don't need to worry about managing servers, networking, storage, or hardware. The platform handles the infrastructure. Pre-built environment. Platform-as-a-service platforms provide ready-made environments, often with support for a variety of development frameworks, languages, and tools. Multi-tenant architecture. Platform-as-a-service is typically a multi-tenant environment where multiple customers share the same infrastructure, but each customer's resources and applications are logically isolated. Support for DevOps. Platform-as-a-service encourages automation, continuous integration, continuous deployment, and DevOps workflows, which help streamline the development process. Self-service and on-demand. Platform-as-a-service resources can be provisioned and managed by developers through simple interfaces or APIs, making it flexible and on-demand. Applications of platform-as-a-service. Web applications. Platform-as-a-service is commonly used for hosting and scaling web applications, including e-commerce sites, social media platforms, and content management systems, or CMAs. Mobile backend development. Platform-as-a-service solutions provide backend support for mobile apps, offering API hosting, data storage, user authentication, and push notifications. Enterprise applications. Large businesses use platform-as-a-service to develop, deploy, and manage enterprise-grade applications, including ERP, that is, Enterprise Resource Planning, and CRM, that is, Customer Relationship Management, systems. IoT applications. Platforms can support the development of Internet of Things, or IoT applications with built-in support for managing device data, connectivity, and analytics. Microservices and containers. Platform as a service is also ideal for deploying applications built with microservices architectures, where different services can be independently scaled and deployed. Data-intensive applications. Applications that require heavy data processing, example, data analytics, AI or ML applications, can benefit from platform-as-a-service platforms offering integrated databases, computing resources, and specialized libraries. To summarize, Platform as a service is a cloud computing model that provides developers with a platform to build, test, deploy, and manage applications without the need to manage underlying infrastructure. It offers several benefits, including cost savings, faster development, scalability, integrated development tools, and reduced maintenance overhead. However, platform as a service also has drawbacks, such as limited control over the infrastructure, potential vendor lock-in, and performance issues. It is widely used for developing web and mobile applications, enterprise systems, IoT solutions, and data-intensive applications. Thanks for watching the video.